Welcome back to Best Math. This video is about the exponent rules. We will start with the definition. Let x be a real number and n a natural number. The expression x to the n is called the power of the number x such that x to the n power is just x multiplied by itself n times. Now we are going to make examples. 3 to the 4 power is just shorthand for 3 times 3 times 3 times 3 written 4 times. And similarly, square root of 2 to the 7 is just square root of 2 multiplied by itself 7 times. Another example, negative 4 over 7 to the 5 power is equal to the negative 4 over 7 multiplied by itself 5 times. When we write this expression, a to the n power, the number on the bottom is called the base, and the number at the top, telling us how many times we're multiplying the base by itself, is called the exponent. Sometimes it's also called the power. Now we will pass to the exponent rules. In all the following, let a and b be two real numbers and n and m two integers. We start with the product rule. The product rule says that if I have a to the power of n times a to the power of n, that's the same thing as a to the n plus n power. In other words, when I multiply two expressions with the same base, then I can add their exponents. We will apply this to examples. For example, if I have square root of 2 cubed times the square root of 2 to the 4, that's equal to square root of 2 to the 3 plus 4 power, equal to square root of 2 to the 7. And that makes sense, because square root of 2 cubed times square root of 2 to the 4 means I multiply square root of 2 by itself 3 times. And then I multiply that by square root of 2 multiplied by itself 4 times. And in the end, I have square root of 2 multiplied by itself 7 times. I'm just adding up number of times as multiplied in each piece to get number of times as multiplied total. Now we will pass to the quotient rule. The quotient rule says that if we have a to the n power divided by a to the n power, that's equal to a to the n minus n power. In other words, if I divide two expressions with the same base, then I can subtract their exponents. For example, I will ask you what is 5 to the 7 divided by 5 to the 4. Well, here we notice that the two powers have the same base, so we will keep the base 5 and subtract the exponents. We will get 5 to the 7 minus 4. That's going to be 5 to the 3. And this makes sense, because 5 to the 7 means I multiply 5 by itself 7 times, and then I divide that by 5 multiplied by itself 4 times. So, when I cancel out 5s, I have 3 5 left. Notice that I have to subtract the number of 5s on the bottom from the number of 5s at the top to get my number of 5s remaining. That's why we subtract our exponents. Now we will pass to the power rule, or power of power. The power rule tells us if we have a to the n power raised to the n power, that's the same thing as a to the n times n power. Simply, when we raise a power to a power, I get to multiply the exponents. Now we will apply this to an example. For example, 7 squared raised to the 4th power is the same thing as 7 to the 2 times 4 power, which is 7 to the 8th power. And this makes sense, because 7 squared to the 4 can be thought of as 7 squared multiplied by itself 4 times. Let's write this expression another way. That's 7 times 7 times the same thing, times the same thing, times the same thing again. So I have 4 groups of 2 7s. That is going to be 7 to the 8th power. We are going to make another property. Distribute an exponent over a product. This rule says that if I have a product, a times b raised to the n, that's equal to a to the n times b to the n power. In other words, we can distribute an exponent over a product. We apply this to an example. For example, 4 times 8 all raised to the 3rd power is equal to 4 cubed times 8 cubed. And this makes sense because 4 times 8 all raised to the cube power can be expanded as 4 times 8 multiplied by itself 3 times. But if I rearrange the order of multiplication, we will get 4 3 times multiplied by 8 3 times. That's going to be 4 cubed times 8 cubed. Similarly, we can distribute an exponent over a quotient. If I have a over b all raised to the n, That's equal a to the n over b to the n. For example, 3 over 7 all raised to the 4. That's the same thing as 3 to the 4 over 7 to the 4. And this makes sense because 3 over 7 all raised to the 4 can be expanded as 3 over 7 multiplied by extra 4 times, which can be written as 3 multiplied by extra 4 times divided by 7 multiplied by extra 4 times. And that's going to be 2 to the 5 power over 7 to the 5 power as wanted. We have seen that we can distribute an exponent over multiplication and division, but be careful because we can distribute an exponent over addition or subtraction. For example, e plus b to the n is not generally equal to e to the n plus b to the n. And similarly, a minus b to the n is not generally equal to a to the n minus b to the n. We will verify this with a counter example. For example, 1 plus 3 squared is not the same thing as 1 squared plus 3 squared. The first term is equal to 4 squared, which is 16, and the second term is equal to 1 plus 9, which is 10. Another example, 2 minus 1 squared is not definitely equal to 2 squared minus 1 squared. The first term is going to be 1 squared, which is 1, and the second term is going to be 4 minus 1, which is 3. The next rule is about the power of 0. What happens when I raise number to the 0th power? First, 0 to the 0 power is undefined. Now, let a be a non-zero real number. A to the 0 power is always equal to 1. Usually, this is taken as a definition, but this makes sense if you have something like a to the n power divided by a to the n power. Certainly, that has to equal 1 because anything divided by itself is just 1. But here, we notice that the two powers have the same base, so we can use the quotient rule. We get a to the n minus n power is equal to a to the 0. Therefore, any number raised to the 0 power is just 1. For example, 2 over 3 all raised to the 0 is equal to 1. Another example, square root of 3 raised to the 0 is equal to 1. Let's move on to the negative exponents. Now, we are going to ask questions. What happens when we take something to a negative power? Let a be a non-zero real number. A to the negative n power is the same thing as 1 over a to the n power. Again, most people just take this as a definition, but here's why it makes sense. A to the n power times a to the negative n power by the product rule is equal to a to the n plus negative n is going to be a to the 0, which is 1. Now, we have a to the n times a to the negative n is equal to 1. If I divide both sides by a to the n, I get this expression. And here, we have the right to divide by a to the n because it's non-zero number. We will simplify by a to the n. We will get a to the negative n is just 1 over a to the n. So that's where this rule about negative exponents comes from. For example, 5 to the negative 3 is just 1 over 5 to the 3. Another example, square root of 7 to the negative 5 is equal to 1 over square root of 7 to the 5. Now, let's look at the fractional exponents. Let a be a real number greater or equal to 0. What does an expression like a to the 1 over n really means? Well, it means the nth root of a. For example, a to the 1 over 3 power means the cube root of 8. That's equal to the cube root of 2 cubed, which happens to be 2. Another example, 25 to the 1 half means the square root of 25, which is usually written without that latest superscript up there. We will finish this video with a note. A over b to the negative n is the same thing as b over a to the n, with a and b non-zero reals. When the base is in the form of a fraction, we can flip the fraction, but on condition of changing the exponent sign. For example, 2 over 5 to the 7th is equal to 5 over 2 to the negative 7. For example, square root of 3 over 4 to the negative 9 is equal to 4 over square root of 3 to the 9. Finally, if you like this video, don't forget to subscribe to the channel and hit like and activate the notification bell to receive new videos. See you next video.